Physics knowledge. So we only talked about one of the simple machines. We talked about the inclined plane. Okay. Today we'll talk about a few more. And really, these are, you can be thought about as sort of versions of an inclined plane because they're really different types of inclined planes, different configurations. So we'll talk first about a wedge. Okay. And a wedge is basically an inclined plane, a double-sided inclined plane. And so what's another word we might use for a wedge? Like a more common term. If you look at all these things, what'd you call them?
Blade.
A blade. Right. Okay. A wedge is really a double-sided inclined plane. Okay, you can think about it, it's just an inclined plane. And the wedge sort of can help you to transfer downward force. As you push down on the wedge, transfer that force into outward force that can split something or cut something. Has anybody had to split firewood? Okay, use with just manually or with a log splitter? Manually with one of these?
Yeah.
So how does this work, Jack, since you've done it? What do you do?
You just swing it.
What is this thing though?
Next.
No, not
Oh,
quite.
no, you put the, I forgot what it's called, you put it in there, and then just hit on it, so it keeps going farther and farther down the split.
Yeah, you put this wedge into the wood, and then you hit it with a sledgehammer. And what happens is the downward force of your sledgehammer is then applied to this outward force of the wedge and eventually splits the wood. You can have a gas-powered log splitter that does the same thing. It just it uses an engine to force the wedge into the wood, but works in the same principles. Blades are examples of these this type of simple machine. Okay, anything that's pointy. And a longer, thinner blade, okay, gives you a greater mechanical advantage. So what do you do if you're sharpening? Maybe you've seen somebody sharpen a knife or scissors. What are you actually doing?
You're making the edges, kind of like you're kind of making I can't really explain.
Okay, you
it.
want to add it?
Yeah, I know what it is.
Yeah.
Basically, when you're sharpening a knife, you're basically making the edge thinner.
Yeah, you're making that edge thinner, make that gradual.
So you're not really sharpening the blade, technically.
Yeah, you're making that wedge thinner. All right, so that's all we need to say really about a wedge. And we'll look at a knife when we do some examples of this. The screw is really another type of inclined plane. You're going to take an inclined plane and wrap it around a cylinder. You have a screw. What's that? No, that's not what I was looking. I was looking for a little piece of paper. Maybe I lost it. Oh, here we go. So if I take we imagine this is a screw. Right? If you take a screw that has, what are the things that wrap around it? The ridges of metal? Well, but what do we call them? Like
Threads.
the threads of a screw. Okay? You can imagine like this is an inclined plane. If you were able to unravel the threads of an inclined plane, okay, what do you get? I mean, the threads of a screw, you just get an inclined plane. Okay? And so we can use these, a threaded cylinder, a screw, for lots of different purposes. Obviously, in a screw, we use it to attach, objects together. What's another tool you use to attach objects together besides the screw?
A nail.
A nail. What do you think a nail would be an example of?
Wedge.
More like a wedge. So if we think about a nail versus a screw in terms of how you get it into the wood, which requires more force? The nail. You have to hit the nail with a hammer, right? Exert a lot of force. How about a screw? Luke? Yeah, it's just sort of using one hand, you're just kind of twisting it in. Again, what's our trade-off? Yeah, you have to twist that through a whole bunch of times to get it into the wood versus just smacking the nail with a lot of force. Yeah, but we're talking simple machines here. So a screw is also used for things like fastening, like the lid of a jar, like a mason jar lid. Has threads on the inside. That's an inclined plane. A drill bit, an inclined plane. Here we're using a screw to, you know what this is?
Yeah. Oh, it's one of those things they have in the book.
It's like a car jack.
It's a jack. You put that on your car. Has anyone ever had to change a tire? You guys take driver's ed in high school. One of the tasks you need to do is change a tire. In the back, the trunk of your parents' car, you probably have a jack like this. Okay? And what it does is it allows you to lift up a car just by turning this simple screw. You don't need to exert a lot of force, you're just turning this, okay? And again, you turn this, I should have brought one in. You turn this jack, you have to turn it 1,000,000 times, but it will eventually, not actually 1,000,000, but it will lift the car using just simple force, okay? It's multiplying your force. It's a simple machine that allows you to do that. So a screw is also an example. Now you'll see, and you'll look at this tomorrow when we actually see these. I have 2 types of screws here. Okay? And what's the difference between them? Here, pass them around. So
this one goes upwards.
As we pass those around, you'll look at the threads of those screws. What do you notice about them, Jackson?
These are just like straight, but this one goes up.
Well, they're not quite straight. They look very flat, but they're actually inclined slightly. What does that mean about those screws? Anybody? So if the threads are relatively flat versus very steep,
Oh,
what does that mean? Well,
It'll be easier to do, but
which one?
the one that has like more straight.
Yes. We call those fine threads versus coarse threads. And the one with the fine threads takes very little force, but you have to turn it a lot more times to actually get it into the wood. Okay? Steeper the threads, the less the mechanical advantage. So one of the things that you're going to do for those screws that I'm passing around is you're going to be calculating their ideal mechanical advantage. So if we look at this screw, if I look at this screw, how could I find the length of this inclined plane? It's on a, I can't unravel.
Like multiply the
Melt.
Yeah,
Try to measure like the length of one of the threads and then melt it.
Okay. How can I measure the length of a thread?
with
Tape measure.
A ruler's not going to work very well.
Tape measure.
If I take a string
Oh
and
yeah.
I wrap it around each thread and then unravel it, I'm going to have the actual length of the threads. And that's what you'll do tomorrow. So we can do that. And when you do that, let's say we do it with screw A. We find the length of all those threads is 16 centimeters. What would its mechanical advantage be? Ideal. 8. If I look at this other screw with the steeper threads, it only has 8 centimeters of threads. Its mechanical advantage would be?
4.
Okay, 4. So they both have a mechanical advantage. Which one could I get into the wood using less force?
Hey.
Hey, I would have to not exert a lot of force turning that screw, but how many more times am I gonna have to turn it?
A lot.
Twice as many times. So I could turn this one, let's say, 20 times to get it into the wood. This one, I would have to use more force, but I could maybe turn it 10 times. Finally, wheel and axle. Oh yeah. A wheel and axle is another type of, who needs this? Another type of simple machine. And a wheel and axle has a rotating wheel mounted to a thin axle. Okay? And a wheel and axle is used to multiply your force. To find the mechanical advantage, we measure the radius of the wheel part, the larger part, and we measure the radius of the narrow axle in the middle. So here, what do I have? What is this? It's a doorknob taken out of a door. Has anyone had in your house the doorknob part fall off? Come off? Did you ever try to just turn that threaded rod to try to open the door? It's really hard. That's because you're losing the wheel part. You're losing the mechanical advantage that that wheel gives you. So to calculate it for this example, our ideal mechanical advantage would be the radius of the knob part, 12 centimeters, divided by the radius of the rod, 2 centimeters. This would give us a mechanical advantage of 6. Okay. And what this allows us is to multiply our force. Some examples. So, obviously any wheel and axle is a wheel and axle. A doorknob. So again, this doorknob allows me to exert very little force to withdraw that bolt. In fact, this is a wheel, even though this doesn't look like a wheel, imagine it's a wheel that's this big around. They just removed this part or never made this part. So that's the radius of this wheel. If you look at a doorknob back here, which gives a greater mechanical advantage? The handle on that door or this one? That one. This one is a much smaller knob, a much smaller wheel. Has anyone ever used a boat lift like this?
Yeah.
So this you'll see like people have a boat on a lake or something. You pull your boat up, okay, into the dock area, get out of the boat, and then you have this big wheel that you turn, and it will lift the boat out of the water. So how many people have used something like this? A couple? So Luke, when you use this, you can use your force to lift a whole boat out of the water, right?
Yeah.
But how many times do you have to turn that?
A lot.
A whole bunch of times. And the bigger this wheel,
The
the more turns you have to do, but the easier it is. So you have this huge wheel and you just turn it, and you can lift the boat out of the water with just one hand by turning that wheel. You just have to do a whole bunch of times. It's multiplying your force. When I learned how, there's an example too. When I learned how to drive, my grandfather owned a road construction company. I learned how to drive a big 15-ton dump truck. And he would take me in the dump truck, I'd drive it around his garage, but the steering on this dump truck was a huge thing, and you have to like turn it like this to move it. And the reason that steering wheel was so big is you needed that mechanical advantage. It had these, dump truck had huge tires on it, and you needed a great mechanical advantage of that steering wheel to actually be able to turn those wheels. All right, any questions about these simple machines? We'll use them tomorrow.